Okay, problem number 5 for test 1 review. Force of 500 newtons with a direction of 56 degrees north of west. So it's a vector problem again. And another force of 350 newtons are applied on an object. Okay. This one, the 350 newtons, should actually say 350 newtons down. Okay. So one of them is 56 degrees north of west, and the other one is 350 newtons down. What is the magnitude of the net force on this object and its direction? So it's a good case of vector addition. This time we have to get the actual answer, right? So the visualization of the problem is that you have some kind of an object, maybe a little block or something. You have a force of 56 degrees north of west. So this is west. 56 degrees north of west means like this. 56 degrees north from the west direction. And this is 500 newtons. 500 newtons of force. So we can call this vector A. And then we have another force that is applied in the down direction. So like this towards the south. Okay. So that would be which way? This way. 350 degrees, 350 newtons. So this could have said down or it could have said south. Okay. So that means it's pointing this way and this one is pointing this way. So this is vector B. Okay, this is vector A. So what is the net force? Well, we're gonna say the net force. We can call them this way. The net force is equal to F1 plus F2. So A could be the same as F1, and then this one is going to be F2. B is going to be F2. So how do we do this? Well, we have to break each one to its components, right? So we have to say F net X is equal to F1X plus F2X. And then we have to say F net Y is equal to F1Y plus F2Y. Okay? So what is the Y and X component of F1? Well, in order to do that, we need this traditional angle, right? The 56 degrees north of west, that's measured from the west. But what would this angle be? So this angle would be 180 minus 56. So what is that? Well, 180 minus 50 is 130, and then 6 more, so the 124. So the X component is going to be cosine of that. So F net X is going to be 500 cosine of 124. How about F2X? Well, the X component of this, well, you see from the picture that it really doesn't have an X component. It's only in the Y direction, right? Down. So its X component is 0. The other way you can say the X component is 0 is because the angle, its angle is what? 270, right? The cosine of 270, if you do 350 cosine of 270, what are you going to get? Well, cosine 270 is going to be 0, right? So that means that that's another way of saying that the X component is 0. How about the Y component? F net Y, F1Y, well, it's going to be 500 sine of 124. F2Y is what? Well, that one, definitely there's a Y component. What is the Y component? Well, it's actually the whole thing, negative 350. It's headed down. So negative 350. So now you have to go to your calculator. You have to make sure your calculator is in degree mode. Okay, let's make sure it's in degree mode. Go to mode, put it on degree. So now you're going to do 500 cosine of 124, which is going to give you, let's write this down, so the F net X gives you negative 279.596 newtons. That's this one here. And then F net Y is equal to what? 500 sine 24, 124 minus 350. 500 sine 124 minus 350, which is going to be 64. 64.519. I'm rounding it to 3 decimal places. Now, what's going to be the total force on this? Now, in terms of a vector, what is this giving us here? Well, the vector way of adding these is to take this, as we did this earlier in the question 15, take this, to put it to the tip of this, right? So F1 plus F2, that's equals to F net here, right? So what does this represent, the negative 279? The negative 279 represents this number here. Negative 279, right? It's the x component. What does the y component represent? Represents the vertical component, 64. So you can see from the picture, this one and this one is sort of going to cancel each other. You're going to be left with a small y component, then you're going to have a big x component, right? So now how do I get the magnitude of the total force, right? If this is negative 279 and this is 64, how do I get this? Well, I got to do square root of 64 squared and 279 squared, right? So I'm going to take this one here. The F net is going to equal square root of negative 279.596 squared plus 64.519 squared, and then square root that number. So negative 279.596 squared plus 64.519 squared, you get something like 82,336. Then you square root that. That gives you the total force. I have 286.94. Okay, that's going to be newtons. Okay, so now how about the angle? How about its direction? Well, to get the direction, how do you get the direction of a vector? Well, you already know this is a certain angle theta, right? This angle theta. So in order to get the direction, you say tangent of theta is 64 over negative 279. Tangent of theta is the y component, y divided by fx. So you have 64.519 divided by negative 279.596, right? So what do you get there? Tangent of theta equals 64.519 divided by negative 279.596. You get this number, negative 0.2307579, so on. Now I want to know what's the angle. What is the actual angle? Well, I have to take the inverse tangent of negative 0.23, right? Tangent inverse of negative 0.2307579, and then you get the negative 12.994 degrees. But we know that can't be the actual answer because negative 12 degrees would be down here, right? So this is negative 12.994 degrees. So what's the actual answer? Well, this and this are vertical angles. They're the same. So in order to get the actual answer, I add 180 to this, because what I want to know is, what is this answer? What is this answer? From the x-axis to the net force. So I add 180 to this, it takes me all the way there to the opposite side in the second quadrant, right? So add 180, and I get 167.005. So pretty much close to 167.01, you know, if you round it up. So that's going to be the angle as measured from the positive x-axis. The other thing I could have done is I could have taken the absolute value here, 64 over 0.956. I would have gotten positive. I would have gotten positive. I would have gotten positive 12. Then what I would have said is this. 12.994 is this small degree, so subtract it from 180. Take it away from 180. So then I would have done theta is 180 minus 12.994. Then I would have still gotten the same answer, 167. Okay? So that's the answer to that problem.